through right now, though. Yes. Okay. Any questions from your homework? Any of the assignments? All right. Then we will get started with the lesson. So a 5-5 is the beginning of factoring. So 5-5, 5-6, 5-7, and 5-8 are all factoring. So we're teaching you some patterns to kind of speed things up. And then we're just kind of revisiting some things, and then we're expanding upon some things. But it's a lot of factoring. Now this right here, we are starting with because you always start with this. If you're going to factor something, you always check, does it have a greatest common factor? Always, 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 always. It doesn't matter what the problem is. If you are going to factor, you always start with the greatest common factor. So you've been finding the greatest common factor for quite a while now. You did this in L1. You did this in intermediate or geometry. You've done this for a while. If we look at this right here, this 2x plus 4, if I look for the greatest common factor of it on the whiteboard, it's just 2. I can take 2 from both items, and then we would write it in factored form. So we're going to do the same thing here. Now there's 2 thoughts behind it. I'll show you the option I like the best. And then after that, I'll show you another option, and you can kind of decide that. So when I look at this, I just look at numbers, and then I just look at variables. And so I'm going to start with the numbers. What can I divide 5 and 55 by? 5. So I'm going to write 5 down. So this is the start of my GCF, my greatest common factor. Then I look at the x's. Quick hint about your x's. Whatever the lowest x is how many you can take from all. Now, there's an exception there. If I put plus 5 here, can I take any x's out? No, because not all 3 terms have an x. But since these 2 are the only 2 that are there, I just look at this and x cubed is the lowest, so I'm going to say that's how many I can take from each of them. So that's my GCF. It's not factored, but I found the hardest part. I put my parentheses there. I have 2 terms right here, so I should expect to have 2 terms inside my parentheses. And this is the method that I like. I just think of it like this. I like to multiply. So I go 5x cubed times what is 5x to the 4th? Yeah, just x. Because 5 times what is 5? 5 times 1. And then I need 1x to get me from cube to 4th, so I put x. Done. Then I look at the next. 5x cubed times what is 55x cubed? 11. Thank you. So I get plus 11. Now, if that sign right there is a minus sign, then I would put a minus sign down there. Okay, that's typically how it goes. Unless I factored out a negative, but we don't do that too often. So I'm putting a box around it, but you always want to ask yourself, could I factor this more? I can't factor this more, so it's done. But that's it. So that's option 1. Option 2, you still have to think about your greatest common factor. What can I divide both of them by? That's really the same thing. Once you know that it is 5x cubed, though, you can divide. It's really doing the same thing. So I can look at it like this and say, okay, what can I divide this by? Well, that cancels out, and this leaves me with just x. What's this? This cancels out, and it leaves me with 11. So I'd have plus 11, and then I take whatever I divided by and put that out in front. I don't like that option as much. I think that's more work. However, if you do like that option, go for it. Okay? Questions? You try number 2. So you have 3 terms, so your parenthesis has to be a little bit bigger because you're going to have 3 terms in the parenthesis. But you get your greatest common factor out there, and then you write it down. And I'm going to be walking around. You've gone. Okay.
I hope that's right.
Alright. Greatest common factor is what?
X squared.
Perfect. What goes inside here? Now, this is where some knowledge is going to get dropped on you, so watch out so it doesn't hit you in the head. Or maybe don't, because you want to make sure it does. Either way, here you go. I look at this. I'm just factoring the greatest common factor out right now. So if you stopped right here, I'm happy. However, this is the last time you're ever going to stop here. Okay? When we factor something, we want to factor it completely. Can I factor this piece right here? The x squared plus 5x plus 6.
Yeah.
Yeah. So what multiplies to 6 but adds up to 5? Perfect. And it doesn't matter if you do 3 and 2 or 2 and 3, it's the same thing. But so I read it like this. So if I ask you on the test to factor completely, which I will, that would be your answer. Okay? You take the greatest common factor out, that would be like 1 point. You started the problem, you did it very nicely. Then to get it to the next piece, that would be your next point. Okay? Questions? All we're doing today is looking at GCFs and the difference of perfect squares. Now, I've talked about difference of perfect squares before. However, if you take a look at number 3, I would always ask you, can I take the square root of 3? Can I? No. So you can't do the difference of perfect squares there. But I also told you something else. When I'm factoring, I always start with the greatest common factor. What's my greatest common factor for 3 and negative 27? 3. So I'm actually going to take that out. So I'm going to put 3 down, and then I'm going to have x to the 6 minus what? 9. Good. I'm going to start asking you a lot more questions so we get used to no calculators. So, I'm here. Now, the thing you want to watch out for is if you got 2 terms, you got to look for the difference of perfect squares. So 2 terms just means term 1, term 2. Then what you got to look for is my first power even? So is the x to the 6 an even number? Yes. Now, when I take the square root, we draw that little symbol, okay? But really that symbol is the same as the 1/2 power. Now remind me, what is x to the 6 to the 1/2 power? 3. It's x cubed. Because when you have power to a power, you're multiplying. So really you're just cutting it in half, okay? So if I'm doing the difference of perfect squares here, I would write it like this. I cut this in half and I get x cubed and I get x cubed. I will also connect this to conjugates because they are going to be conjugates of each other. You're going to have a plus and a minus. So what's the square root of 9? 3. So I'm going to have plus 3 and minus 3. And it doesn't matter if you have minus 3 and plus 3. It's the same thing. But so this is factored completely. Now with cubics, you do have to check, but you don't know that yet. And you don't have to actually factor this more. So I'm not going to make you. So that's it. Done. And you can't. Now on the board here, I have the generic formula. Okay? So if I have a squared minus b squared, the difference of perfect squares, it just goes to this. Okay? And we're going to just use that on the next couple problems. And then you're going to get time to practice. So, when I look at number 4, we are doing the more difficult ones together. What's my greatest common factor for number 4? 1. How many x's? 2. So I can take 2 x's. So I'm going to factor out x squared as my greatest common factor. So I'm going to put minus 49. How many x's do I have left if I took out 2?
6.
Yeah, we have 6. So we have 6 because I'm just doing division, really. Or I'm multiplying. You got to think, x squared times x to the 6 is x to the 8th. So that checks out. So that's where that comes from. Now, you kind of have a template here for what it's going to look like. I'm going to have the x squared on the outside. I'm going to have 2 sets of parentheses. X to the 6 goes down to x cubed. So I got x cubed and x cubed. And somebody already said the square root of 49. 7. Yeah. So it's going to be, and this time I'll write it different to show you it really doesn't matter. Minus 7 plus 7. That's my answer. You guys get 1 and 2. Try it out.
I'll use my calculator.
Now you can.
Better get used to it now.
Oh, just nickel my store calculator.
The square root is 45.
What's the square root of 16? You get 90? What's the square root of 4?
So you're gonna have 4x.
Inside.
Inside. There's no greatest common factor. So you got 4x plus the square root of 25.
That's what I got.
So you got 4x plus 9.
I don't know. Wait.
You do both. So just like down here. That plus 9. It's just the pattern that always happens.
So then it's gonna be double.
Yeah, pretty much. So plus 9.
Is there a greatest common factor for this first one? No, there's not. So,
Yeah, I know.
all I'm going to do here,
I'll take it back.
all I'm going to do is put up my parentheses. And so I follow my pattern. My pattern says AB, AB. So what is the square root of 16? 4. So I got 4x. So I put that in both of them. And then I have 25. What's the square root of 25? 5. So I got 5 and 5. And these are conjugates, but I just put plus and minus in there. And it doesn't matter if you have the minus and then the plus or the plus and then the minus. So let's talk about this just a little bit more. Can I factor anything else in here? No. So I'm going to put a box around it. But I got to ask myself that. 2. Square root of 81. 9. Square root of x to the 4th. Yeah, x squared. So I'm going to start it with 9x squared and 9x squared. There was no greatest common factor on this one. Square root of 16 you already told me is 4, so I'm going to have plus 4 and minus 4. Can I factor it anymore? You can. So these problems are the problems that continue to give. Okay? You know, it's the Christmas season. It's the giving season. This is a factoring problem that's that same way. So here it goes. So I cannot factor this. And you're like, why? Is that the difference? No, it's the sum. It's the addition of two perfect squares. If you factor the sum of two perfect squares, you get imaginary numbers. We don't make you factor with imaginary numbers. So we actually just leave that as it is. So 9x squared plus 4. When I come to this next one, though, what's the square root of each number? 3 and 2. So I write that as 3. Is it x squared or just x, or is it x cubed? What is it? Just x. Because I got to cut that in half. So I get 3x plus 2, 3x minus 2. Done. Maybe. Can I factor more? No, because the other one gives me imaginary.
Wait, so you only factored like the negative?
Only factor the negative. The positive we can't factor. The positive don't write this down. I'm going to write it in red. Do not write it down because I don't want you to factor this. Would be 3x plus 2i and 3x minus 2i. We don't make you factor the imaginary part, okay? So you stay right here. And that is your solution, okay? Questions? All of you people thinking it's homework time. It's not. What are we gonna do?
No paper left.
We're gonna go pink, pinkish paper. So we're gonna do a solving problem now. But before we do that, is there any problems? If anyone needs paper, there's paper over there. Or you can just do it on a blank sheet of paper.
This is special.
Special paper. All right.
To get better.
Any questions before we stop this lesson?
No, it's not that bad.
Okay. Then I want you to copy down this. We're gonna solve it. Okay?
I want to do synthetic efficiency.
You want to do synthetic again?
It was so
We actually could do synthetic.
all for real.
Maybe.
I don't know how to do that.
Oh,
We're good there. Alright. You also do want to have this little picture here, because without this little picture, you can't do anything. Or you could say given, and you could put that point down. You could say given that. Because otherwise, you got to do a little bit more work, and I'm not making it that much work, just a little bit of work. And we're going to do one other thing. Take all your calculators, tuck them away. Now, I am not saying you can't pull your calculator out and type something in quick, but we're going to be doing some mental math and practicing it.
you should probably put that.
So,
That's how you calculate. Don't eat.
how many solutions should I have for this problem? I should have 3 because we are at degree 3. Do I have any solutions? Yes. What's one of my solutions? X equals 1. So I'm going to put comma, x equals, and x equals. Now, we could have, this is a cubic, so it could turn and it could come back down and go back up, and we could have 2 real solutions. Probably not, though. Or it could go up here, and somewhere way the heck up here, or way the heck down here, it could have did this, and so we got 2 imaginary solutions. We're going to figure it out, though. So, solving a cubic, we don't have really an option other than to change form. So we got to change it to factored form. We have one solution, so we can do either synthetic or long division. What do we want to do? Synthetic. All right. So I'm going to write this down, but you're going to tell me where to put the numbers. So what goes on the outside here? 1. Yeah. So solutions go on the outside. If you get to long division, it would be the factor. So we got 1. So sometimes we give you the factor instead, and then you have to flip it. Now let's list these numbers. What's going to be my first number? What's the next one? What's the next one? Yes.
Ooh.
Oh,
0. Why is it 0?
because there's not an X.
There is not an X, so we need a placeholder. Then I put -9 down. All right, you do the synthetic, I'm going to do the
I
synthetic.
hate this game. Oh, I got the answer right.
Now, am I asking you what the remainder is? No. What am I really looking for here? Yeah, I'm looking to break it apart into pieces and look at it. So we're going to do this. What's the factor that relates to 1? What's the factor that relates to 1? Boom. X minus 1 is the factor that relates to 1. I'm not going to do a whole lot with it because my solution's right there. Next, we have to write this lovely piece of synthetic in there, okay? And I'm even going to put down that this equals 0 because that's really truly what I'm solving for is, my solutions there. So now this is going to be 5x
Squared.
perfect plus 9x plus 9. So I told you already we're going to ignore the x minus 1. Not because it's not there, not because it's not important, but because we already have the solution. We already wrote it down. Do not assume if it's on the graph that I accept that as a solution. You need to write it out. Okay? You need to put x equals. You need to show that that is one of your solutions. So, do you want to factor that? Yeah, not really. Okay. Do I want to complete the square with that? Why do I not want to complete the square with that? We only ever completed the square when a was 1. A is 5. It's a whole heck of a lot more complicated. So I'm not going to do that. Also, b is an odd number, so that's not nice. So then, what's my option? Quadratic formula.
Are we supposed to do with our calculator?
Oh, don't worry, we're gonna get through it. It's not too bad. I actually just
What
worked.
happens when it does get?
I just worked through actually a mock test, and it was pretty good. No calculator. I made the numbers pretty decent, but we're getting used to it. So I'm gonna start. You should have the quadratic formula somewhere. It's also somewhere up here, right over there. So what is A? B is 9 and C is 9, so that's not too bad. So I'm going to start opposite of B, -9. Plus or minus, square root. There's a lot of numbers going in there. I'm coming back to it. What about 2A? What's the bottom going to be? 10. Okay, so B squared is 81. Look at that fast math that we got going here. And then -4 times 5 times 9. Okay, when you're doing math without the calculator, use the little thought bubbles. So let's think about this. 4 times 5 is what? I'm going to ignore the negative for a moment. I'm going to put 81 minus 20 times 9. What's 20 times 9? 180. So I'm going to put 81 minus 180. And then I'm going to put my equals here. And I'm going to have -9 plus or minus square root of something and 10. What's 81 minus 180? 99. Yeah. -99.
Yeah, we got the curve is great.
No.
Yeah.
No.
Can you curve it for the people who didn't take the calculators?
Actually, we have never curved an ELGE 2 test.
So you can make it. This can be your first.
Sorry.
About to set a record.
Now, we got that. Give me two numbers that multiply to 99. 9 times 11.
Yeah.
Why do I like 9 times 11? Because it's easy. It's pretty easy to deal with. And, you know, when I look at this, I'm going to get x equals, so now I'm bringing it back this way. I get x equals -9 plus or minus the square root. I'm going to put some numbers in there. I'm going to put -1, 9, and 11 in there. And I'm multiplying all of them. So, let's finish this problem off. -1, what's the square root of that? I. So you can say I1 if you want.
I'm
That's
already
fine.
forgetting the.
Okay, so what's I? Square root of 9?
3.
Square root of 11? Yeah, we don't know.
Recalculate.
So I put 3i square root of 11. How many solutions do I have?
I don't know.
2. So I'm not going to write them way the heck back up there. I'm just going to put a lovely little box around it, and I'm good. If you box your answers for me, I'm happy. Okay?
So we gotta find the third one.
Do we have to find the third one?
No, because it's plus
No,
one.
it's already there.
No, it's already there. We already wrote it up top.
Where?
It's right here, right there. We wrote it right up above it.
1, 2, 3.
Yes.
So why was the quadratic formula like necessary in this situation?
Ooh.
It was necessary because, one, we couldn't factor this. Okay, we got an imaginary solution, we couldn't factor it. We could try to factor it. I skipped that because it's just really nasty numbers and we would have figured out really quick that it wouldn't work. Okay, So then the next piece, you have complete the square. Complete the square. Not too many of you like that, so I don't really push that too hard on you. But the other thing is, that's 5. You've only ever completed the square when it's 1 right there. And if this is 5, you have to do a lot more. There's a lot more to it. So that's also why I shied away from that. And then there's the Shrek method. That's our last option other than the quadratic. And the Shrek method, you can't have that.
What is the Shrek method?
So because we have this, we had to use the quadratic. Okay? Quadratic's kind of like the hammer. It works for everything. It always works.
But like we already got us to the point of knowing that the one comes here is a solution.
Yes.
So then would we use the quadratic formula for the
We
other
used
solution?
we used it to find the other 2 solutions.
Okay.
Because it's a cubic, so it has 3.
That makes
So
sense.
you gotta find 3. Yep. That's good. Thank you for asking that. Other questions?